Welcome back, everyone, to Merge Conflict, your weekly open source AI developer podcast. I'm one of your hosts, James Montemagno, and with me, as always, the one, the incredible, the man that just lost his cell phone, wallet, all of his credit cards into the Puget Sound, Mr. Frank Krueger. How's it going, buddy?
Thanks, James. That was a wonderful introduction. You brought me up and then you set me down. You really have become a manager. But I think you're supposed to sandwich it up, down, up again, right? Something like that. So say something nice about me because I'm feeling terrible. I did drop my phone and my wallet into Davy Jones's locker, the deep, deep, scary ocean.
Well, let me light you up. Let me gas you up. Let me gas you up.
Gas me up.
Because you are a man that not only lost all of this today, but you are the only person that I've known that have done this twice in the last 3 years.
You know, the funny part is the last phone I lost into water was a lake, fresh water, and I got the phone back after a week. And to my credit, like, it's right here. This is the phone I lost in the lake.
Oh my God. It's like, no, didn't you
years and years ago.
Didn't you lose a phone in Lake Washington kayaking?
Yes, James.
Is this the third?
Look,
this is your third.
No, this is number two. Come on now, give me some credit. Look, water and I just don't get along. What do you want me to say? Like, that's just how it is. I am forgetful, and I love iPhones. Those two are not compatible with each other, it turns out.
Wow. Well, you know.
Oh, it's embarrassing. Actually, I picked up the wrong phone. Here's another one. I just have a desk full of iPhones. We are the AI open source podcast, but we're also the mobile development podcast. So I just have phones up the wazoo. It was funny because I dropped my phone and your first question was, don't you have like a dev phone, man? I'm like, yeah, I got 100 of them, but I can't use any of them.
That's true. You cannot use any of them. And it's okay because they're all super old and busted. I mean, I can barely use my iPhone SE2. It works. It's a phone. Mm-hmm. It's a thing.
Yeah.
That is there. Yeah. That is for sure.
Can you use continuity camera? Because if you're watching on the YouTubes, I don't have my happy, perfect, beautiful lit Apple camera. Right now, I'm using a junky old camera. So I apologize for the YouTube quality.
It's kind of cool because if you're watching this on YouTube, you could go from 470, which is high quality, then 471, which is this episode, and then low quality. But then next week, 472, which we recorded before 471, we go back to high quality production.
The magic of movie making.
There you go. Exactly. Frank, something happened. We talked about it at around build time. Yeah. The VS Code team announced that not only is VS Code open source, but they are going to open source the GitHub Copilot chat extension. And it is now, as of June 30th, open source on GitHub under MIT license. That is a very permissive license. I'm going to read the blog post, and then we'll do a Frank Reacts. It's like a Prime Reacts. Prime. No,
I'm ready. I'm ready to react. I'm going to emote. I'm going to do all the emotions.
Why open source? Why open source, Frank? As we outlined previously, our primary motivation is a community-driven innovation and increasing data transparency. I like that. We believe AI experiences can thrive by leveraging the vibrant open source community, just as VS Code has successfully done over the past decade, 10 years of VS Code. As AI has become an integral part of the modern coding experience, it should be developed openly alongside VS Code itself. Explore and contribute. Now the code is open source. What does that mean for you, Frank Krueger? It means that you can explore the code base and learn how agent mode is implemented, what context is sent to the LLMs, and how we engineer our prompts. Everything from our system prompts, implementation details, to the telemetry we capture is all available in all transparency. In fact, why not use agent mode itself for helping you understand and explore the code base? It's actually a good idea. We welcome you to, your feedback and contributions. That's right. Feel free to open a pull request, file an issue. Note that we're tracking the issues on the VS Code repo, as our long-term goal is to integrate all the code from the VS Code chat GitHub repo into the VS Code core codebase itself. So what's next, you might ask? Well, next, we will carefully refactor the relevant components of the extension into VS Code core. That's kind of cool. The original GitHub Copilot extension that provides inline completions remains closed source, but But in the following months, we plan to have that functionality be provided by the open source GitHub Copilot chat extension. That's crazy. Also,
Yeah.
are excited to partner with the open source AI community to make sure our plan covers impactful open source scenarios. Our core priorities remain intact, delivering great performance, powerful extensibility, and intuitive, beautiful UI. We're excited to shape the future of development as an open source AI editor, and we hope you'll join us on the journey. Happy coding, the
Ooh.
VS Code team.
Well said, James. Well said. My reaction is that sounds good.
Yeah.
I'm not sure. Like, I do like their statement. AI stuff should be open, developed in the open. In the end, it's a chat. It's a chat prompt. You type in some things and it does things. The benefit that I see is I've just always been curious. Like, what is it actually doing? Like, how does it actually work? Insofar as I want to write AI enabled apps myself. So it's fun to
Mm.
see how AI experts are writing an AI infused app. So this isn't just using AI to write your own app, but the app actually makes heavy use of AI to perform what it does. And I just wanted to see how that architecture works. I'm not very familiar with how VS Code extensions work. So I was kind of curious about that. And it's just I learned to program by reading other people's code, and I still think it's one of the best ways to learn how to program and to expand your own skill set. So anytime a large company puts out a large hunk of code, I'm always interested. I'll read all of id Software's game code and all that. I'll read all of Unreal Engine source code. It's just you grow when you learn how other people do things. And for that reason, James, what do you think we do a little deep dive into this code? Because I think there's stuff to be learned here.
I'm ready. I did a few things. Pierce was doing a few tweets, posts on the Twitter X, and around some cool contributions they've been getting actually. So people have been contributing on it. Now I didn't take too much deep dive into the code, although I do kind of feel like I want to pull it down and explore it with agent mode. I just kind of open up in VS Code itself. In VS Code, looking at VS Code things with the VS Code agent, and that is like so meta, so deep. It's
It's
like
so meta.
it's
Yeah.
very
And not that
uh,
meta, the other meta. Yeah.
no, but I haven't dived into it at all. So I'm kind of ready to kind of
Mm-hmm.
see what you've gotten into. And of course, full transparency, as we say on this podcast, I work at Microsoft. I work very close to the VS Code team. I'm very biased towards our products. So I'll probably say very good things, but I also, as you will find out in next week's episode, have vibe coded an entire SaaS all by my lonesome with
Ooh,
our good friends GPT-4.1 and Claude 3.5, 3.7, and 3.4 or 4.0. So all the things inside of agent mode. I've
bragging.
been doing lots of it. Well, you'll find out next week, Frank, although you already found out because we recorded yesterday. We'll break it down. What is this? I mean,
Okay.
you
Yep.
explored, you did it. What is this
Well,
thing? Is it just a little chat and that's about it, or what's up?
I mean, honestly, that was my first question. I'm like, if you open Copilot Chat, there's like a little chat window there, and I've written AI chats before. You take some user input, you send it to the AI, it spits something out, you send that back to the user. It's kind of easy to write a little chat thing. But I was surprised. Number one, at just the amount of code that's here. It is not just a little chat thing. There are many, many TypeScript files. This
Mm.
is all written in TypeScript,
Oh,
so
cool. Wow.
I'm pretty sure everyone can read TypeScript. It's just JavaScript with a lot of extra crud on it, so it's pretty easy to read. It's very enterprisey. Everything's a service, a lot of dependency injection. So it can honestly be a little bit frustrating to like dig in and find the code that's actually doing stuff because it's all
Mm.
architected. And sadly, they did not release any architectural drawings with the code. So you just kind of have to dig through a whole bunch of code to find the stuff that actually does stuff, that does interesting things. And that's kind of why I wanted to do this episode, to just start sending people pointers to interesting parts of the code to look at. Because, yeah, at first glance, it's just a chat box. But if you start to think about what it's doing, especially when it's in agent mode, it's executing MCP servers. It is interacting with the text editor. It's dealing with arbitrary random instructions from a user. How does it deal with that? It's dealing with a variety of programming languages. How does it do that? It's dealing with very large code bases. You don't want to just throw the entire code base into a prompt. So how does it deal with that? I think these are all kind of fundamental questions you have anytime you're writing an AI thing. Now, I remember one app you were writing. I'm like, what do you do for the context? How do you manage the data that you're inputting to? And you're like, I just throw it all in the prompt. That's how I just throw it all in the prompt. But
Throw it in
that
there.
you can't do that realistically with a code base. It could be millions of lines of code. It has to do things a little more intelligently, a little more efficiently. Otherwise, we're all going to have giant AI bills in the end.
That's true. Yeah.
So, starting at a high level, I would say, roughly speaking, this thing is an AI talking to an LLM, so it needs to prompt that LLM. So I think that's always kind of the first place you want to go to in a code base like this is just find those prompts. Like usually they're called system prompts. These are the things that the user did not type in. These are the things that the software is providing to the AI to give it
Because
context.
because if you don't have these and you just say, please go implement this thing, it doesn't know. I mean, it's going to maybe try to figure out what that means, but it could
Hmm.
go down 1,000 different, layers. For example, in
Yeah.
my feedback application, I have a system prompt that's like, I am a YouTube comment analyzer. I do these things. This is how I analyze it. This is the thing that I want, blah, 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 blah. Right. And like the user input is like this stuff. And it's like, here's what you're going to receive. Here's what you want to analyze. Here's what your thinking is. And think about it from a data analyst perspective. And like, think about it, read all the comments, understand that they're threaded comments, understand how they're related to, you know what I mean? Like that's my
Hmm.
system prompt. So I could imagine like you are, you know, a
An
program.
advanced code editing agent. You understand many languages,
Mm.
yada, yada. In fact, I think that's easily the best place to start. There is just um, uh, agent instructions, is what they call it. And it's a fun file to dig into. But roughly speaking, I want to start real high level again. I wanted to know the parts, I wanted to know the system prompt, and I wanted to know how it actually interacts with the editor, because if you've used Copilot, it's doing all these like fancy diffs and accept boxes and all that stuff. I wanted to see how it actually talks to VS Code, the text editor, in case I want to port this maybe over to other text editors or things like that. And then I also wanted to know where does it get its data? Because that's always been the biggest question to me. And you mentioned it from that blog post that the inline completions, that's the Copilot without the chat window when you're just typing code and it starts auto-filling in code. Ever since that came out years ago, I've wondered, like, what exact information does it have? Does it have all the data in that file? Does it have all the data from all the files? So I had some big questions I wanted answered, and that's what I wanted to seek out in this code. And I think I found most of my answers. It's a big
Yeah.
code base, so I haven't found everything that I've been looking for.
Well, what did you find?
Let's start with the agent prompt because it is quite good. Um, it's impressive when you're writing these system prompts, but let's just start with, you got to tell the AI what it is. And it says, you are a highly sophisticated, automated coding agent with expert level knowledge across many different programming languages and frameworks. And just off the bat, one of the things I found most funny about this is the system prompt is all written in HTML, and it's a templated HTML,
Oh.
which makes sense when you're writing an app because the user might choose different settings here or there. They're like, oh, maybe it has tool access. Maybe I'm going to allow it to do this. I'm not going to allow it to do that. So the system prompts themselves are templates, just normal
Hmm.
procedural programming templates, so that the app at runtime can change what it's prompting and all that. So I think that that's just already a fun pro tip to start with. Write your system prompts in HTML and make sure it's not perfect HTML. Don't add styling or any of that junk. But also make it templated so that your app can change with options and whatever the user selects. Um, I think the other fun parts are it's pretty explicit, the system prompt, about the way it should go about solving problems. Like, think step by step, read the provided workspace information, understand the user's request, consider how to answer the user. Like, it's almost those thinking kind of prompts first, and
Yeah.
then generate a response that clearly and accurately answers the user's questions. And then, so that's kind of the broad high level of how Copilot should operate. But then there's just lists and lists and lists of do's and do nots
Yeah.
because this must have taken a lot of time to fine tune. It's easy to start with a nice simple prompt, but then you're going to run into like, oh gosh, it did this weird thing one day. Let's tell it never do that again. Please don't do that. Or maybe it's not doing something you do want it to do. You got to say, you must do this. Please do this. And you use capital letters for those. I think we've all learned capital letters are how you really tell the AI to do something or not. So I was kind of interested that it is pretty explicit in how they wanted to problem solve. And its do's and don'ts are pretty explicit. I
Mm.
don't don't just I don't know. Don't just spit code out at the user because this is a chat window. It's supposed to interact with the editor. So don't just start, presenting a whole bunch of code. Instead, do things in a more sophisticated way.
Yeah, it's cool. It's like, hey, never, print out a code block with the terminal command, like unless they ask for it, like, like just use the run in terminal tool instead. Like, you know what I mean? Like
Yeah.
there's, yeah, and that's if it has the terminal tool available, or else it would, right? Never print out a code
Hmm.
block with file changes unless the users ask for it. And that's if they have code search and has some editing tools available to you, right? Like, so that's what's interesting is like when you're in ask mode, it prints out all the stuff. In your video that you did, it printed out all the stuff and you can move it in. You can do all these nice little tools and widgets. You're in the safe space because it doesn't have tools available to it. It's just here it is.
Yeah.
So they're using similar models and instructions in this way. Obviously, different models will perform differently, but that's why it's templated. It's literally, that's kind of cool actually. Like it's just if you have code search, if you don't have code search, if you're in this model, keep going reminders to do this often. Different cool calling to read the file to get more context. So yeah, that's pretty nifty. And in fact, we were talking on the lightning topics about the beast mode, and like this iterative process that you can kind of have and like really put it into this mode to provide these additional rules, right? So that's kind of what it's kind of doing, which is kind of crazy.
Hmm.
Yeah.
Yeah, and you led really well into the next most fascinating part for me is its tools access, because the tools are how the AI actually interacts with the app. In this case, VS Code, not your code, but the app itself, the UI, and all that stuff. And that's the part I'm always curious about because I think when you first write an AI, you just kind of try to parse the response from the AI and maybe kind of roughly figure out how your app should respond, unless you're just writing literally a chat app where you just spit out the output of the AI to the user. But I think we're all trying to make more sophisticated things now. So the tools I found were the most interesting part. And to be clear, these are not MCP tools. These are kind of baked in and very explicitly they are just described to the AI.
Hmm.
Now, with new frameworks like, Apple Intelligence has a way to define tools and to give the metadata around the inputs and outputs, very similar to how MCP works. These tools are very much like MCP tools, but these are the baked in ones. So if I'm writing iCircuit with AI enabled features, I would come up with an appropriate set of tools, and this might take a while to figure out, but a set of tools that the AI can call in order to interact with iCircuit, my app, in order to achieve what the user needs. So I thought it's a, like I said, it's a big tool base, but code base, but I think a wonderful place to start because this is kind of the meat of the problem is looking at the tools, the
Hmm.
implementation of each of the tools in the code base. So I had mentioned in the source code, there's the agent instructions. And then I think the next most interesting part of the entire code base is source slash extension slash tools slash node, a lot of slashes in this code base. And that's where the actual tools, the nuts and bolts of this thing are
Yeah.
actually happening.
When we say tools, and tools have been sort of and you sort of said it, you kind of described it, but like for LLMs to perform actions on the user's behalf, tool calling and the ability to call into things and a standardization of that is the ability to execute functions basically. right?
Mm-hmm.
And that can send things, it can receive things, and it can perform things. And in this case, tools can be kind of extensions of the editor itself to be able to like modify things and do a bunch of things and read context and do things and deeper into the code editor itself. And you'll actually see in VS Code and Visual Studio, there's a different set of tools that are available. Like there's a bunch of tools that are built in for like notebooks, for example, or for like different AI, or for different VS Code extensions or AI or VS Code, like, UI parts and stuff that you can investigate, for example. But MCP servers, so model context protocols, standardize that way. So
Yeah.
in this instance, the tools that are calling are proprietary to VS Code, right? They're not standardized. Whereas MCP servers, which we talked about, is a standardized way for these LLMs that can call tools to invoke tools. So Claude Desktop, VS Code, Visual Studio, the coding agent on github.com can call into these things. So you could have a Figma MCP server that exposes a way of getting design information back, right? For example, you could have the GitHub MCP server for this. So in this case, the tools are editing code or fetching code or investigating and scaffolding things or calling terminal commands or doing those things. That's the tools that you're talking about, correct?
Yeah, exactly. And I got to tell you, the thing I was most impressed and surprised about in this whole thing was just how few tools they needed to accomplish all these tasks.
Mm,
Um, yeah, because I think the granularity of the tools is one of my big open ended questions. Do I write 300 different tools for interacting with the iCircuit engine for an AI? Or do
yeah.
I write a few powerful tools for it to interact with the engine? And in the case of Copilot, they went with the few powerful tools, which is totally cool because that's less code I need to read and
Yeah.
understand to know how this thing's working. But it's
Yeah.
also it's interesting to see that from an engineering perspective that's where they landed. They didn't need 30 tools. In the end, I would say they have roughly 6 tools, honestly, that it uses, and probably fewer, probably on a regular basis. Um, so I thought we'd just go through them real quick because I think that they're interesting from a design
Uh,
perspective.
and I'm opening a VS Code right now. So if you open up VS Code, open up agent mode, there's a little tools icon. You can click on it and you'll see built in. So for
Mm-hmm.
example, there's actually not that many that are built in, to be honest with you. And actually, surprisingly, many of them you might want to uncheck when you're actually doing coding in general.
Mm-hmm.
But anyways, do you want to go through them? I mean, I could list them, but I
Well, I'm
I
curious
think I
which
know the ones
list.
that you're gonna do. Yeah.
I'm curious which ones it's actually listing for you
Okay,
because
I'll tell
I
you.
think there's a
I'll tell you.
distinction
I'll tell you.
between internal and user
Ah,
facing.
so
Yeah.
Oh, that's fascinating too. Okay, so built
Mm-hmm.
in that you can turn on and off changes, which gets diffs of changed files. Makes sense. Code base,
Mm-hmm.
find relevant file chunks, symbols, and other
Yep.
information in your code base. Edit files in your workspace. Extensions, search extensions in the marketplace. Fetch, search content from the web. Find test files, find a source code file, find the file that contains the tests. GitHub
Mm-hmm.
repo searches a GitHub repo for relevant source code snippets. New scaffolds a new workspace in VS Code. Open simple browser opens a simple browser. Problems check for errors in a particular file. Run commands in the terminal. Run notebooks, run notebook cells, run tasks in your workspace. Search and read files in a workspace. Search results, the results of the search view. Terminal last command, the active terminal's last run command. Terminal selection, the active terminal's selection. Test failure includes information about the last unit test failure. Usages, find references, definitions, and other usages of a symbol. I'm pretty sure that one's important. And VS Code API uses the VS Code API references to answer questions about VS Code extensions. So from all of those, I can
Mm-hmm.
tell you, I already know which ones it's probably using, but now you know, so you can see if they mirror
Yeah.
up with what actually you're working with.
Well, now I would argue those are user facing tools. Those are not the actual internal tools. So the what I'm
Mm-hmm.
calling the internal tools are the ones
Mm.
it strictly needs in order to do its job.
Mm.
You're able
Yeah.
to uncheck those. You're able to turn those off because that's a user preference. Do I want it to search GitHub issues? That's totally just a user preference. That's an extra tool, not
Yeah.
necessary for it to actually function. What I like to look at is the internal ones. Like these are the bare minimum. These are the things it needs in order to interact with VS Code. Now there is overlap. Of course, there's overlap. Um, so I break it down into just two big categories: input and output. So how does it get the code it needs? in order to answer your questions, to read your code and all that, and how does it interact with your code. And I
Mm-hmm.
was surprised that for input, there really is, and I think you mentioned this one, there's very broadly code base search. So it can just send out some strings. You can almost think about this as like Googling your own source code. So it can kind of Google your code. It'll throw out some terms, some search stuff, go find this stuff. I think you yourself have implemented this stuff, James. It's usually called RAG, where you are just creating an embedding of the request. You have a bunch of chunked embeddings of data files, and it just goes and looks for overlaps. It's an intelligent way to do a full text search. And that is its primary way to interact with your workspace. And that's good because you might have 2 billion lines of source code and
Yeah.
you don't want a 2 billion token context because A, it's expensive, B, it's slow, and C, it's just inefficient. You don't need it. And so, what you can gather from the agent instructions that we talked about before is it relies basically on two input tools: code based search and read file. So code based search is the intelligent thing, and then read file is exactly what you think. It's given a file name, and it just blurts back, the tool blurts back the entire file contents. So it's kind of
Mm-hmm.
interesting that all the tricks and all the neat stuff that Copilot does, those are its only two ways to actually get data from your
Hmm.
code base. You mentioned other ones. It can do extension searches and get history searches and all that kind of stuff. Those are extra. But if you're just editing some code, these are the ones it uses: code base search and read file. So if you're writing your own app, you'll want rough equivalents of that. Probably most importantly, the code base search. So uh, and then, sorry to keep using my circuit simulator as an example, but it's just, I like to have it something different from a coding agent, just so you can
Yeah.
see, like, so my version of a code based search would be search the circuit for this thing. Like, are there any resistors? Okay, it'll return a list of all the resistors in the circuit. If the user asks for, do I see a voltage divider anywhere? My code-based search could go and search the topology of the circuit, looking for voltage dividers and things like that. So I think when you're trying to AI power your own apps, you have to think about how you're exposing your engine data, your model
Mm.
data to the AI. And for that, you need a tool. And that tool needs to take some kind of search query, and you're going to have to return some kind of results. And so I think it's just neat to see, honestly, that they rely on a sophisticated tool like that to do basically the majority of the work.
Yeah, I always feel like when you're working with the agent itself, it is really primarily doing like two or three things. So it makes sense that those two or three tools need to be like super optimized and super well done, right?
Mm-hmm.
Because when you think about it, it's interpreting a few things based on the prompts, right? Like often, and in the prompt that you see, it talks about like the files and the context that the user is attaching, so it knows more of what you're giving it. That's also super helpful, by the way, when you give it the
Yeah,
thing instead of like having it search
totally.
for it.
Then it's not searching. Yeah,
Yes,
exactly.
it also is smart enough to search, and some
Mm-hmm.
models are more exploratory than others. It depends on your code base too. The bigger the code base, the more it has to search, the more work it has to do, the slower it is. Like if you know the
Yeah.
things, it is the advantage. I was talking to someone like, oh, like, if you're a new developer, like blah, blah, blah. It's like, yeah, you can get far, but like actually like one of the big benefits is like understanding the code base, how it works, the architecture, the files, the things like that. It can do it, but
Mm-hmm.
I think you can do it a lot faster if you have a general idea of how the thing is built. But it can then parse those files and then bring that into the context and then read those files and then output to those files in general. It's mostly reading files, interpreting what you wrote, figuring out what it needs to do, inserting code, removing code, and that's kind of the
Well,
gist of it, if it can. Yeah.
well, yeah, that's the next part, the output. So we just talked about the input. The output, I think, is also fascinating because, especially when you're in agent mode, and if you're like me, you have lots of big file or very few big files. So I have many files that are, 2,000, 3,000, 10,000 lines of code. And you ask for a change. And at first I was kind of scared because I know how LLMs really work. I'm like,
Yeah.
God, is it regenerating my whole file? And then is the IDE looking for a diff and then it's applying the diff? Like, ooh, that's gross and scary. And I'm going to burn through all my tokens real fast if that's how it's working. Fortunately, that's not how it works. So its two primary output tools are replace string.
Hmm.
Makes sense, and we can talk about that, but it's very similar, in fact, to just your normal interactive find and replace in a text editor. And then edit file. It's a separate tool, and they're different from each other, but they're different in just basically the intelligence of the tool. So to go back to previous Frank's thing, no, it is not regenerating the entire 10,000 line file every single time. That would be terribly inefficient. So it's kind of funny, and you can see this in the instructions. So replace string is the most basic one, but obviously it's the most efficient one too,
Yeah.
because you can write the code to go find a string in a file and go and replace it. Easy peasy. But that's only going to work if the string it needs to replace is actually unique and it can just go find it. If you have the same string over and over in the file, but it's only supposed to replace one instance of it, this is not going to work for it.
Yeah.
You can almost think of it as like a regex. It's not using regex, but it's very similar to a regex. And I think they're even using like Levenstein difference to find the string. So it's a little complex. But I like that it has that basic fallback output mode for efficiency. I'm still an engineer. I don't want to burn all my tokens. I'm trying to make a profit here. Whereas edit file is the sophisticated one. And it's neat when you read the agent instructions because they're very explicit about when to use one and when to use the other one from the AI's perspective. Edit file is the sophisticated one where it tries to find actual structure in the file. It'll give it rough hints of beginning, middle, end of the file, that kind of stuff. And it uses a lot more heuristics to do it. What I find interesting is, no, it's not sending it like a patch diff, if you've ever done Unix kind of stuff.
Yeah.
They're not doing it that way.
Huh.
Instead, what they wrote was a very simple tool to do edits, and then, which is replace string, and then a complex tool, edit file, which can handle the complexity of whatever the AI is going to output. And even then, these tools don't just explicitly use like JSON, like go search for this string and replace it. They say, here are markers to use to designate the old code. Here are markers used to designate the new code. In a lot of ways, it is like a diff patch, but it's a custom format that they've obviously tuned over time to find what works well with most models out there.
Interesting.
So I just think the neat, fun lesson for me to learn is a simple tool and a complex tool for doing the actual edits to your data model in an app.
That makes a lot of sense. Yeah. I don't know if there's a lot of history as far as like the history of the thing, but like early
Right.
on in agent mode, it doesn't do it anymore. But what it used to do, at least the UI update visualization, was it would open the file it's editing, it would like kind of scan and show you the diff.
Yeah.
Because that was neat. That's a cool
Yeah.
little thing. And
It's
who
nice.
knows
Yeah.
which one it
UI
was
stuff.
using, or maybe it was using some proprietary one before those two, and they're just using one thing. And that really felt like it was diffing the whole files. It was like, it felt like, here's the file, here's the completed file, diff, merge, go. It did, really look like that. And that was tedious as the models got faster and better and you were doing bigger, complex things, right? As you were, as like, sometimes I kick off a task, an agent, and it'll modify 10 to 15 files.
Oh yeah.
It might
Crazy.
cook
Yeah.
for a few minutes, right? In some complex task, write test, do a thing. And if he was to open every file and like it would get pretty tedium, you know what I mean? In general, compared to like, oh, here's the diff and here you go, boom. So now it kind of just, when you click on it, you see the side by side before and after, right? It's just like, it's done, which is better probably from a performance, just in general.
Yeah, and it's hard to say what's UI versus what's actually doing the data model change, because like you
True.
could do the data model change instantly and then animate the effect to like make it easier on the user. It's, it's standard UI stuff. Just because you can do it instantly doesn't mean you want to display it incrementally. Just for humans, we're funny like that. Um, yeah. So I do wonder the difference between those. But a funny thing in the agent instructions, to your point, it explicitly says run as many tools in parallel as you can
Mm-hmm.
because don't make the user wait around for all this stuff. And that's an explicit instruction. It's like whenever you can, run all the tools in parallel. Because
Yeah.
yeah, you just don't want to waste the user's time. That's an important instruction I totally forgot to bring up earlier. I thought was kind of clever because I've never put that in any of my system prompts before. So that's kind of
Yeah.
fun.
I never thought about that either, but it does make a lot of sense because if, yeah, you get back and here's the thing, and it's like, oh, I'm going to do these 4 file changes, or I'm going to do
Mm-hmm.
this thing and that thing. Like I'm going to, read 4 files at once. Yeah. What don't read, blah, 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 blah. Just put them all in there. It's kind of
Yeah,
cool.
yeah.
Nice.
And then the other tools are uh, the other big one is just run in terminal. That one just comes up constantly when you're reading
Mm,
through this code base. They're less important. Like I said, the input output ones are kind of the core ones. Those are the ones I was interested in as an app developer trying to integrate AI into my apps. Like, what do I have to provide?
yeah.
Um, you gave a long list of all the other functional tools, but the run in terminal is just kind of a fun one. And run in terminal is so powerful that in a lot of their instructions, they have to tell it when not to do that. As in, like, because you could edit a file from the terminal. You could use sed, you could use grep, you could use awk, you can
Yes.
use all these powerful things. And it's like, don't do that. Use the
Well, like
custom tool for that.
what's super fun is actually to watch these tools evolve over time. And like things can change week to week. And I've noticed
Okay.
this and that I've probably done this like because especially when I was working on feedback flow, which is the same code base for several months at a time, using
Hmm.
especially insiders, right? They're tweaking these prompts and things like that. But I definitely noticed that there was at one point when it was early on when it could like start to run terminal commands by itself
Yeah.
and do stuff. It's like I'll just
I do
start
everything in the terminal.
cat.
I'm a terminal
I'm
hacker now, yo.
I'm gonna read this file, just cat it out. I'm gonna like, oh, dude, like, what are you doing? It's running like all like it can do some crazy stuff in the terminal. Like I
Yeah.
had it recently help me like revert a big command. It's like I'm gonna run all these git commands and next command that thing. It's like I'm gonna understand what this file did 4 commits ago, and it's gonna like, oh,
Hmm.
that's so cool. Like it's cool that it can just like tap into those things. But yeah, sometimes it's a little bit much. I will say this: what it seems to be doing a lot now, which I actually kind of like, and
Okay.
both in Visual Studio and VS Code seem to do this now more than ever, which is it does its changes. Like, what I'm going to do? I'm going to build it. Like, I'm just going to build it
Oh,
for you.
nice. Just doing it,
And,
man.
and it's like, it knows what files it changed in what project. So it's like, I'm going to build this project. If it's like, seems to be like
Okay.
more than 2 or 3, or it'll be like, I'm going to run this project. I'm going to build this project. Then, what I'm going to do? I'm going to build the whole solution and then I'm going to run the unit test. We're going to see what happens. And especially it's pretty quick. And then it's like, cool.
Yeah.
I'm going to make sure everything's good because now that it can not just run in terminal, it can also read the terminal, right?
Yeah.
So what's nice is I assume, and this is probably an LSP thing, is because not all LSPs are created equal. It is better to run a build of your application than to rely on the problems and the errors that are coming from
Mm,
the LSP. That's
interesting.
my assumption. I do not
Interesting.
know, but makes logistical sense.
Yeah, I don't actually have an opinion on that one. I need to take more advantage of the continuous building and testing stuff. That's where I'm weakest right now. You're ahead of
Oh
me
yeah.
there. You're more sophisticated than I am. But now that I've been able to read this code, I can see all the power this thing has, and I'm going to become a much more power user because now I'm like, oh, I can see it can do that. It can do that. It can do that. Fun
Nice.
benefit of reading the source code.
You should do a video on this. Well, we're doing a video on this right now, but you should. Yeah.
more deep diving. Yep.
Well, because that's what's interested in me is like we were talking about beast mode, and Burke was like spending a lot of time on understanding the OpenAI docs and how GPT-4.1 works, right? Just like if you understand how the model works, you understand how
Hmm.
the tool works, you can use that tool better, right?
Yeah.
And I rely this to everything we've done in life The first time you ever got on a bike, you know how that bike works. You've seen people ride a bike, but you've never been on it. Your body doesn't know, right? You don't know what you're doing, right? First time you turn on this camera, I know what I'm doing. I'm autofocus, manual focus, video mode, forward camera. I know what I'm doing. But now I just go bloop, turn it on. It's like good to go, right? Yeah, zoom. I do this. I do focal. You know, I got the bokeh.
Mhm.
So the more you get deeper into it, and you can understand that, especially if you can see under the hood, right? You open up.
Yeah.
If you were to open up, not your car because it's electric, but if you were to open up one of our cars and you see the engine, I look at them like, that's scary. You could close it, right? You just like look at the source code. But if you dive deeper, you say, oh, this is how the battery works. This is how the washer fluid works. And then guess what? You could also then understand, like, you know, how
Yeah.
to use your system better. It's a good
How to
analogy.
win at racing.
Yeah,
To
yeah.
finish
And
the analogy. How to become a racer.
my Subaru Forester, smart car 4.2. Perfect.
So I think we covered actually the most important parts, especially if you're diving into this code. These are the things. Start with the agent instructions and then dive into the tools because those are the most important things. Every app that has AI in it, you're going to have to do those steps. But now I just want to talk about some fun things I learned in it. My last open question was we talked about its code based search and all of that. But again, I'm an actual ML person. I wanted to know the details like, how exactly is it creating its embeddings? Because an embedding is just a numerical code that hopefully semantically represents a whole bunch of text. And the closer these numbers are to each other, the more similar two disparate pieces of text are. I wanted to know actually how it's chunking my code together.
Ah,
Does it have, a custom TypeScript parser? Does it understand C# code? Does it? I wanted to know exactly how it's creating its embeddings and everything. So what I've learned is it does a little bit of everything.
no, yeah.
So for some programming languages, they have custom parsers.
Ah,
For other programming languages, they rely on VS Code's built-in like file tree, where the LSP that you mentioned before, the language server protocol, that itself can break up a code file into chunks and sections. So it can say, okay, this chunk represents, it can include sub what am I saying? It can include little branches off the tree if it can. The chunk boundaries become semantic boundaries versus just textual boundaries. It's not just taking every 512 characters and turning that into a chunk. It's actually looking at semantic information within the files,
mm,
and it does that differently. Some languages, like I said, custom parsers. Other ones relying on VS Code's already its existing ability to do that. Other ones they use this real popular general parser out there called Tree Sitter. So it's fun to see that Tree Sitter is sitting inside this code base. Other times it just looks at indentation. If it doesn't have custom code for any of those, it's like, oh, you indented that. That
well,
obviously is separate from this other part.
it's definitely YAML if the indentation looks exactly this way.
Yeah, that was probably put in there just for YAML. Yeah, I don't. There's probably a YAML custom thing in there.
F
Yeah,
sharp, I guess. Maybe is
you're
F
making me
sharp
want to.
is
Well,
indentation.
that's the most programming languages use indentation, and indentation's we use indentation to break up semantic concepts in programming. It almost doesn't matter what programming language, unless you're talking about basic, but even Visual Basic uses indentation.
Yeah.
COBOL, even modern COBOLs use indentation. Fortrans, yeah, but any modern language, indentation's a great signal for figuring out boundaries for important parts of the text. And then, of course, if none of those are working, it does fall back to I'm just going to read as many characters as I can, fill up the embedding buffer, and then spit out a chunk. So it's funny. I had the question of how is it breaking up the file, and the answer is in every way that you can think of, because it has to deal with all the world's source code, and it is using every trick it can. Obviously, it wants detailed parsings if it can, but it'll fall back to just plain old reading in characters out of a text file if it has to.
Yeah, dude, like what's really fascinating about that is one thing I love working with the agent. We've talked about this many times. I love to read as fast as I can, possibly, like what the agent is doing. It's like really enlightening because it tells you what it's doing. And
Yeah,
some
I
models
ignore
tell
it.
you a little bit more. Yes, some people ignore it, but it gives you little details. Like there's little details about like how it's chunking, like what lines it's reading, if it's reading the whole file, if it's
Mm-hmm.
doing this. And I'm assuming it's going through this process of calling these different in different chunking and embeddings and the codes and the tools and the things. So what you're saying resonates with me, because I think as I've used it so much, I've noticed how it gathers information differently based on like the code and the files and the things that it's doing. Or if I just give it like a JSON file or some blob, or sometimes I'll give it like, here's like a random, like, JavaScript that's like compressed. So it's like a single line of, you know what I mean? Like
Yeah.
it's going to do its thing. So that's really fascinating to see how it learns and figures out those chunking and embeddings and things like that. Crazy.
Yeah, and that'll be important to you if your data model in your app that you're trying to AI power has a very large data model. Like maybe you're accessing an Oracle database or something like that. You're going to have to figure out a good chunking strategy. I remember the first
Mm.
time I used O3, it was terrible. Like I'd give it an entire code base and it's like, I'm reading line 6 of this file. Now I'm reading line 12 of that file. I'm like, we are not going to make any progress if you're reading these things one line at a time.
Oh
So
my gosh.
I think figuring out your search, embedding, chunking, whatever you want to call it, strategy is very important. The way you're getting data into the context and into the model.
Nice.
Anyway, I just wanted to bring that one up because that was just a big pending question. Like, how does search work? How is it actually finding stuff in the code? And the answer
Yeah.
again is in every possible way. Whatever
Yeah.
they got, whatever
Nice.
trick they can pull, they'll pull it. And I think that that's actually a harder part of when you're implementing this stuff is figuring out that strategy.
Yeah.
And then the last fun thing I just want to bring up, just because we talk about them all the time, you can see how MCP servers are actually integrated. So we talked about all the built-in tools, and I distinguish between the internal built-in tools and the user-facing tools. But then users can just add tools via MCP servers. And so I do recommend reading the source code. It's just under source extensions, MCP. And it's just fun to see how it integrates all the various MCP servers. So if it has 12 MCP servers, it has to inject their descriptions into the instructions. It has to inject all the available tools into the system instructions and all of that. And so I just think it's a fun little bit of code to read also because, again, if you're writing an app that's AI powered, you might find yourself wanting to be able to, you might become an MCP client, as in
Yeah.
you're calling out to MCP servers. And here is an example of how to become an MCP client. And so I just think that's a fun bit of code to read also.
Yeah. I like it's kind of crazy. I'm just reading it. It's like, yeah, the MCP server the developer is asking about uses this command, but it may need additional arguments or environment variables to function. Think step by step, read the documentation, call the tool, use the information, translate the command, return the resulting JSON in a markdown code block. Then do this thing. It's like, I always
Yeah.
love these steps because you're describing what you want it to do, like it's like a child. It's like, hey,
Yeah.
so here, this is a dog, and the dog is an animal, and
You
this
pet the dog.
and
Don't
you
kick
do
the
this,
dog.
but like the dog likes this, you can tell it doesn't like this. But then if you do this and you do this, and it's okay to pet it this way, but not this way. And then we do this, and you can give it a treat, but you want to hold it this way. You know what I mean? So it's just like really,
Yeah.
it's fascinating. It's like that's how you talk to like a little kid. You know what I mean?
Yeah. And
And
it's also,
sophisticated adult too.
well, it's also improving my prompting skills because these are all very tested, very battle worn prompts.
Yeah.
And it's interesting to see what's explicit and what's not explicit. Like it's funny that they have to tell it read the manual. If the MCP server provides directions, please read those and pay attention to those and obey them.
Yeah.
Um, I often would forget that kind of line. Like I would just assume, of course, if I'm providing a description, the LLM's going to read it. But no, you have to tell it prioritize. Really do read this. We're not messing around here. Don't pet the
We
dog that
swear.
way. Pet the
We
dog this
swear.
way.
Yeah. That's cool. Well, thank you,
Yeah.
Frank, for doing a deep dive in this code. And as we were recording, I texted Pearson Burke and I said, recording a podcast with Frank. Frank said he's impressed. So that's good. I like that. Yeah, I
Well,
think this is really neat. I mean, VS Code has been open source for so long. There's so much open source happening in the world of AI. Like, I think this is a pretty pivotal moment in time, just like when VS Code was open sourced and the innovation that came from that and the ecosystem that evolved. And it'll be really fascinating to see now what folks do to kind of contribute from open source onto the tool and what's accepted into the code base and how it merges into the core code base over time as well, which I think is
Yeah.
fascinating, which I think is like the right move. I think that makes a lot of sense. As I definitely personally, obviously biased here, but like using these tools, no matter how little or a lot you use them, like there's no escaping it. It's kind of like IntelliSense. There's, and IntelliCode at the time, like you just adapt to how you work with the tool, um, whether that's code completions or adding comments or asking it about the code or querying or ideating with it. You know what I mean? Like it's something that's like that. And I was just telling you before the pod, I started making thumbnails for our podcast, and I'm just using Microsoft Copilot, which is like the desktop app, and I'm just like, yeah, make a YouTube thumbnail that has this cute cattle dog, does this thing that has these words, and it's like, here you go. And I was like, damn, that's so good. It's too like
Wait till you
when
start using the Genmoji.
oh my gosh, when you so I'll restate this because I've told this a lot with my team and with you and with everyone is when you use these tools, if you've used them 6 months ago, 3 months ago, a month ago, a week ago, things have continuously evolved, continuously changed. If we linked, and I'll add links to the code files that you referenced, these obviously have hash commits, but if you were to
Mhm.
then flip to main, they'd be different because it's gonna
Yeah,
they're
probably.
probably they're probably already different because there's going to be
Yeah.
tweaks and this and that and all these little things. And just like we were saying, I remember in some of our team chats, like, oh man, it seems like the agent is just like using the terminal way too much. And then like a week later, it's like not using the terminal at all. You know what I mean? Like, yeah,
Yeah.
it evolves because these, like you said, these never do this, always do this, prefer doing this, definitely do this. The order of operation and the words matter and how it interprets it, right? It's really
Mhm.
fascinating. So the tools you use continue to evolve. This is funny because next week we're going to talk about feedback flow. I was talking with my report and colleague Bruno, who's like our Java advocate. And uh, he uses like ChatGPT, the desktop app, all the time. And he uses custom GPTs. I've like never seen this
Nice.
like before.
Yeah. They're
And I
they're
was like
cool.
talking about feedback flow and like how I built this and stuff. He's like, check this out. I was like, okay. He's
Okay.
like, I'm gonna create a GPT. I'm gonna give it a prompt, which is, hey, you're a social media analyzer. Like, I'm gonna give you a link to like
Yeah.
Reddit or YouTube. Go find all the comments, do all the thing,
Mhm.
give me a breakdown, a report, and blah blah blah. And like just did it all.
Yeah.
And
Yeah.
I was like, he's like, see, I just like he's like, I built your app in 5 minutes. I'm like, dude,
Yeah.
that's
But
great.
he
I mean,
did it.
obviously
Yeah.
different, but I was like,
Yeah.
dude, that is so cool to see how your mind thought about solving the problem versus how my
Mhm.
mind started thinking about this high level system and sharing and I thought this and that.
Yeah.
I'm still very happy with what I built, by the way. So no shade. I just thought it was like, wow. Like I would have never thought of going to like some AI tool to be like, I'm trying to accomplish this thing where I think I need an API. I need this thing. You know what I mean? I was like, oh, that's really fascinating to kind of think
Yeah.
of how these are. And then I was like, oh man, it'd be really fascinating to expose these tools to give it better context, to give it an MCP thing, to actually do some things like, why am I generating the port? Maybe we could do this thing. So he
Mhm.
had some really good ideas. I just thought it was so crazy because I would have never thought about that. Like maybe when I started building the tool, maybe that didn't exist. You know what I mean? Who knows?
Yeah.
Or maybe it wouldn't have
Well,
been able to scrape it correctly. I have no idea. But I was like, dang, that's so crazy. So crazy.
yeah, and I do recommend sorry, this goes back to what I've been saying the whole time, like, the end game here is the AI is the app at some point. If we ever get a powerful enough one at some point, it becomes the app. But it's not presenting an ideal user interface to you. Those are almost like command line tools at some degree because user interface is not going away. I don't care how intelligent your thing is. I would almost argue user interface is the most important part now because it turns out the model and the algorithm and all that stuff turns out that's easy. We can have
Yeah.
AIs generate that. I think we're ideally, in my ideal world, we're going to have a UI renaissance where people realize that interface is what actually matters. The rest is just trivial stuff.
Yeah, because I do think that like the chat interface itself, like it does a thing, but it's never going to provide the rich functionality that
Yeah.
you can have a handcrafted UI that can present
Hmm.
things in a specific way and create these great, like very subtle touches. It's built for a specific use case and functionality, which is great.
Yeah.
But I do agree. I think already what I've noticed is that people are able to build prettier, more functional things faster. Now, I'm not necessarily saying it's like the best security, it's the best whatever, but I'm noticing that these models, right, have really
Yeah.
picked up on how modern things, how
Yeah.
accessibility works, how these things work in general. And yeah, it's relatively impressive. So, anyways,
Mhm.
I appreciate your deep dive into this in general, Frank. This is really awesome. And I want you to dive deeper into the code, but I'll put links to all the different sections that you did and to the blog post and, of course, the GitHub repo as well on here. Anything else you want to add, Frank, before we dip out?
Nope, nope. There's a lot of code there, everyone, and whatever interests you. I was coming at this from the perspective of I want to AI power my apps.
Hmm.
I'm not so interested in writing a code agent. That's just I'm probably not going to sell that app. Other people are doing it. They're great. What I wanted to know was how do I AI power my apps, and this is a great example to learn from for how to AI power VS Code. VS Code was not AI powered when it came out, but now VS Code is a very AI powered app. So this is the bridge. This is how you AI power something. And so a lot of code there. Ignore all the services, dig through it. You'll find actual functioning code at some point, and take from it what you can. I just hope we provided a good overview.
Yeah. And let us know what you think. Go to our YouTube, youtube.com/at merge conflict FM. You can subscribe. You can also subscribe in your favorite podcast application. That's going to do it for this week's Merge Conflict. So until next time, I'm James Montemagno.
And I'm Frank Krueger. Thanks for watching and listening.